Alright guys, so here, let me go back. So this is a new lesson where we're going to talk about multiplying and dividing rational expressions. So we talked about simplifying rational expressions. Now we're going to talk about multiplying and dividing them. So what you're going to learn in this lesson is how to multiply and divide rational expressions and how to find extraneous solutions. We went over these in class, these vocab words in class already, so the same words we're going to need to use for this lesson as well, so you can write those down in the book and get the definitions from your notes from yesterday. Alright, so operate and simplify the following and give the extraneous solutions. So from your vocab, well, there's three things we need to do here. We need to operate, and we need to simplify these, and then we need to give the extraneous solutions. So extraneous means what would make the denominator equal 0. That's what we're trying to figure out with these problems. So we're going to start with the first one first. So the first thing to identify is what's the operation. Right here you see multiplication. So all you need to do, you can go through and rewrite this all on one line for the top, and then one line for the bottom. And as I taught you in class, you look for bases that are the same. The a doesn't have the same thing on the top, so you're just going to write 2a squared. You have 2b's on the top, and there's 2b's on the bottom, so both of these go away. And then there's a c at the bottom, so you keep that. So we simplified this. We performed the multiplication, then we simplified, and it says give the extraneous solution. So here c just cannot equal 0. So the ES is c can't equal 0. Because if I set that equal to 0, it's going to make the denominator equal 0. Here we have a fraction divided by another fraction. So when you're dividing rational expressions, then you do keep, change, and flip. Or keep, change, take the reciprocal, keep the first, change the divide to multiplication, and then you're going to take the reciprocal, which means here to flip that fraction, and then you're going to do exactly what you were taught to do with multiplying. So in this case you get x minus 5, and I'm going to put that in parentheses, times 12 over 6 times x minus 10. When something is a binomial and you're multiplying it, make sure you put it in parentheses. Now we're going to go through and simplify. If you look here at the bottom, these two numbers, if you use decimals, you can simplify. You get 2. 12 divided into 6 is 2, and then we get x minus 5 over 2 times x minus 2 times 2x times 10. That's a binomial. So the top is completely simplified, and if you look at the bottom, it is not completely simplified, because if you look at this binomial, there's what we call, sorry guys, there's what we call a greatest common factor there. So here we're going to go to the side and get our greatest common factor. And then you look at these two numbers and you want to get the greatest common factor for 2 and 10. If you need help with finding the greatest common factor, then by all means you can use Google. So you get 2, 1. For 10, you get 10, 1, 5, 2. And I think that is all. And then if you need all the pairs and you forget one, just go online and see what the greatest common factors are. So if you look, the greatest common factor they have seems to be 2, the one with 2 in it. That's the biggest number they have in common. They also have 1 in common, but we want the biggest number they have in common. So that's going to be 2. So for my denominator here, I'm going to write that numerator out again. And then for my denominator, I'm factoring out the greatest common factor. So we know the biggest number they have in common is 2. So I'm going to put the 2 here. And on the outside, when I broke that 2 down, what was left was 1. So I can put 1x here. And then when I broke that 10 down, keep the minus. When I broke that 10 down and took out the 2, I was left with 5. So here, if you notice, this and this goes away, and this goes away. So your answer to that is equal to 1. And your extraneous solution is going to be, you don't have none. You don't have any for this case. Okay, so let's go to another one. It says the same thing: operate, simplify, and find the extraneous solutions. So we have another situation where we get 5n plus 15, and if we do that operation, then we know we have to, this is multiplication, so we know we need to go through and put those binomials in parentheses, so we can get one whole line. Okay, if we start with the top, we're going to look in each binomial and see if there's a greatest common factor. So we need the GCF for this first one. We need to figure it out. So I get 5 and 15. So if I write my pairs out, 5, 1, then I get 5, 3. What is that? 2, 5, 3. 1, 15, and I think that's all. It looks like the greatest common factor they have a 1 in common, but it looks like the greatest one they have is 5 they have in common. So here for this first one, then I know I'm going to take out the 5, and when I take out the 5, I'm left with the 1. And then if I go to the one that multiplies to give me 15, when I take out the 5, I'm left with 3. And then next, I'm going to go and do 2 and 4. And some of these you may start learning off the top of your head, and you won't have to keep doing this method that I'm showing you. But until you learn them off the top of your head, then just keep going. The biggest number they have in common is 2. So I'm going to circle this one and this one. And then, so if I go and, oopsie. So if I go and take out the 2, then for the first one, I'm left with 1n. And then the second one, when I take the 2 from the 4 side, I'm left with 2. So that's my top factored out. So now I need to do the GCF for the bottom. That's 4 and 8. And well, we already know we did 4, so you get 2 and 2. And then for 8, you get 8, 1, 4, 2. And the biggest number they have in common is 2. So here's that pair with both 2 in it. So, oh wait, no, I was wrong. The biggest number they have in common is 4, not 2. They have 4 in common. That 4 and this 4. So here, if I take out the 4 in them both, I'm left with 1n plus 2. And then the next one is 3 and 9. And as I said, babies, once you get better with this, you'll be able to go faster, and you won't need to keep using this box to help you out. It'll become automatic to you. And then 3 and 3. So the biggest number they have in common is 3. So 3, and once I get the 3 out, I'm left with a 1. And the other one, I'm left with a 3. And so here, I'm going to go and scratch out what's in common. And I'm left with 5 times 2, which is 10. Nothing else is left at the top. And then I'm left with 4 times 3, which is 12. You can always use decimals to get simplest form for this, but if you know how to reduce your fractions, if not, just push the ABC in decimals. But to reduce your fractions, you want to find the biggest number that they both have in common. And it looks like the biggest number both of these have in common looks like it's going to be 2. So if I divide the top by 2, I get 5. If I divide the bottom by 2, I'll get 6. So the answer is 5 over 6. And the ES in this case, since the denominator is a whole number, we're going to say there are no extraneous solutions here. Okay. Alrighty, so let's go to the second question. So here, it wants me to operate, simplify, and give the extraneous solution. So if we look here, this is a divide sign. So anytime you're dividing rational expressions, we're going to keep the first one. Keep, change, flip. Keep, change, flip. Okay, so now I'm going to do exactly, well, we're in a situation where, all right, we have trinomials. So I'm going to break these trinomials, each trinomial down to a binomial before I actually put everything together. So in order to break this down to a binomial, I need to factor it. So I'm going to go to the X box. And remember the X box for this first one, the A is 1, the B is -2, and the C is -8. So in the top, you do A times C, so 1 times -8, which is -8, and then we put -2 here. So we're going to list all of our factors of -8, and if you need help with finding those factors for -8, then you can use Google. I know I can do 1 times -8, and I want to see, is this the factor? And this side is going to be the sum, and we're trying to get -2 out of that. So here 1 times 8 is -8. And then I'm going to get -1 times -1 times 8, which is -8. If I add this 1 minus 8, then we get -6. -1 plus 8 gives us +7. The other factors of -8 would be 2, -2 times 4, and then the other one is -4 times 2. If I do the math, -2 plus 4 is +2, and then -4 plus 2 is -2. So it looks like this is my winning combination right here. They multiply to give me -8, but they sum, or I would say add, to give -2. So here my factors are going to be -4 and -2. And remember, when we learned the X box, you put that over the A, and then to get the factored form, you do x minus 4 over 1 and x minus 2 over 1. 1 doesn't change anything, but we don't like the 1 up under there, so we're going to do the slide rule and put 1x minus 4 and 1x minus 2. You don't have to necessarily write the 1 because -4 divided into 1 is 1, so you just end up with -4 and -2. So you could have just wrote x minus 4, x minus 2. So that's what this factors, and you'll do enough of these. You can use the same letters as M that they have. You'll do enough of these where you'll start learning this stuff off the top of your head. So that's the factor for that one. And then I'm going to go and do the factor for this one. So I'm going to erase this, and I'm going to do the X box again for the second one. And as you get faster, you'll get faster at picking out your factors too. So for the second one, A is 1, B is 7, and C is 12. So I'm going to factor that down to a binomial. So my A times C is 12, and my B goes right here for 7. So I'm going to do the factors of 7, and then what do they add to? So the factors of, the factors of 12, and what do they add to? Hold on. Factors of 12, and we're trying to get those that add to, we're trying to find that add to 7. That add to equal 7. So I'm going to start with 1 and 12. Well, we know that's 13, so that doesn't work. We're looking for 12 and 1. We know that's 13 again. 4 and 3. Oh, look, we straight. 4 plus 3 is 7. So I'm going to do 4, 3, 1, 1 under that. And as I just said in the last problem, we know this just equals 1. 4 divided into 1 is 1. Is 4, and 3 divided into 1 is 3. So here I'm going to do x plus 4, x plus 3, and I am done. X plus 4, x plus 3. Alright, so now here, I'm in a situation where now I can do, well, I'm just going to write the bottom down. And as you get better, you don't have to write all of these steps. You'll find your own way to do it that will save you some steps. But until you learn completely, then just do it the way I'm asking until you find a way that works for you. Okay? And then alright, so my bottom is not completely simplified. I see greatest common factors here and a greatest common factor here. So I'm going to go ahead and do my GCF for 8. And then as you get better, you'll move away from this chart. As you get better with this. 4 and 2, those are all the factors. And remember, if you miss factors, just go to Google and ask the greatest common factors of a number. Or not even greatest common factors, are pairs of, what are the factors of 24? What are the factors of 8? Okay, I think I got them all. So it looks like the biggest number they have in common is 8. So that's this. So for this first one, I'm just going to write the numerator down. Oh, wait, guys. This shouldn't say X. This should say M. Sorry. Use the same letters that are in the problem. It's just natural for me to use X because most mathematicians use X. Okay, so forgive me. Make sure you use the same letters, guys. Okay, so here, if 8 is the greatest common factor, then here you get 8m. If I take out the 8 here, the 1 is left, and if I take out the 8 for the 24, the 3 is left. So that's what I get there. Now I'm going to go do 2 and 8 for the second problem. So 2 times 1, and then here I get 8 times 1, 4 times 2. So the biggest number they have in common is 2. So we're going to use that pair. If I take out the 2, then the first one I'm left with a 1. We'll put the 1m in front. And then the second one I'm left with a 4. And you notice I didn't write the 1 because 1 doesn't really make a difference. It doesn't change the problem. So here I'm going to go scratch out what I have for matches. And then I'm going to write the answer at the end. Alright, so that is the answer, but my extraneous solution, if we're going to say there's none, because nothing is going to make this denominator equal 0. So we're good. Alright. So you try these 2 problems out, and I'll see you in class. Bye.